Let's take a look at some more polar coordinates questions, and in particular, the geometry behind the questions. So we'll be thinking about the sketches. We might be using Cartesian coordinates, we might be using polar coordinates. Before we start this, just a bit of a recap. Don't forget, polar coordinates are just another way of representing our Cartesian coordinates, which is like our x and our y coordinates. So if you think about the coordinates x, y, like we've moved x across, we've moved y up, we can instead define it as an angle and a distance from the origin. So clearly from this we can see that x would just equal r cos theta, and y would equal r sin theta, just by resolving. Using Sohcahtoa, you've got your adjacent, you've got your hypotenuse. So obviously, as well as that, we could say, well, x squared plus y squared is equal r squared, which sometimes will also be useful. So that's stuff we should know already from last year. Let's take a look at the question then. So we've got a curve with equation r times 1 plus cos theta equals 2. And the first part of the question says, find the Cartesian equation. So if you want the Cartesian equation, we're thinking about the equation in terms of x and y. So looking at this, how could we start? We've got r times 1 plus cos theta is equal to 2. I've noticed if I expand this out, I'm going to get r plus r cos theta equals 2, and we know r cos theta we can write as x. So r plus x must equal 2. I want to use r squared. So there's two ways of me getting an r squared here. We could multiply the whole equation by r, which would give me r squared, but if I do multiply the whole equation by r, I'd get x times by r, and I'd get 2 times by r, and it wouldn't be really useful. Instead, if we just rearrange, don't square it straight away, because if you do square this, remember you can't just square things individually. If I was going to square straight away, I'd have to square everything. You don't want to do that. So r would equal 2 minus x. R squared would equal 2 minus x, all squared. So r squared would be x squared plus y squared, which would equal 2 minus x, all squared. So there's our Cartesian equation. I might actually expand this out because we can see that we can tidy this up a little bit. So expanding the bracket, we get x squared plus y squared equals 4 minus 4x plus x squared. So y squared would equal 4 minus 4x. And in the question it does actually say, I didn't write it, but in the question it says in the form y squared equals. So we've got it in that form. What would this look like, just out of interest? Okay, we know what x squared graphs look like. Y squared graphs are parabolas that go like this, aren't they? So if we were asked to sketch this, not that we are in this question, but if we were asked to sketch this, we could think about it as this sort of parabola. Okay, I'm actually going to draw it on the graphical calculator as well, so we can see what it looks like using the polar function. So if I change the type to r equals, because it would, if I rearrange this, it would be 2 divided by 1 plus cos theta. Okay, so if we draw this, we get a parabola. Right. Yeah, I knew it was going to be a parabola shape, but actually because it's got a negative, the parabola actually goes like this. Let's zoom out a touch. You can see we get this sort of shape here. If you were going to sketch this as well, without just reaching for the graphical calculator and be doing it in the x and the y world, you could think about it as y squared is equal to minus. You could take the minus 4 out if you want, but it'd be x minus 1 if you took the minus 4 out. And you can see the roots at 1, because if we sub 1 into this, we get 0, don't we? So when x equals 1, we'd get y squared equals 0, which means the roots at 1. Okay. But let's see what the rest of the question asks for. So part B says the line with equation 4r equals 3 sec theta. Well, maybe let's just think about that for a second. Like, that doesn't look like the equation of a line to me. It tells us it's a line. Okay. Now I'm much more comfortable with the Cartesian world than the polar world. So maybe if we just have a look at this for a second and think about, okay, well, it's telling me it's a line. What would it look like as a Cartesian? We've got 4r equals 3. Sec is the reciprocal of cos, so it'd be 3 divided by cos theta. So if we rearrange this, we've got r cos theta equals 3 over 4. So this polar line is actually the line r cos theta, which is x. So we can think about that as the equation x equals 3 over 4. And if we go back to our sketch, we knew the root was at 1. X equals 3 over 4. So if you think about your axis, the line x equals 3 over 4 would look like this. And we're aiming to figure out the 2 points where it intersects. It says the line intersects the curve at the points P and Q. And we actually want to figure out what the length is between those two values. There's 2 ways I can do this now. I might show you both ways actually. And depending on how the question's set up, my advice would be sometimes it's easier in Cartesian form, sometimes it's easier in polar form. Okay? If we were going to go down the polar route, you could say r would equal 3 over 4 sec theta. And we're thinking about, so when this intersects this, we'd get 3 over 4 sec theta 1 plus cos theta would equal 2. So if we're going to do the intersection in the polar world, we think about when this polar intersects this polar. Sec we know is 1 over cos, so we'd have 3 over 4 sec theta plus 3 over 4. When we do sec times by cos, it's like 1 over cos times by cos, so that would cancel. So rearranging this, let's multiply everything by 4, 3 sec theta. Multiply by 4, that would be 8, and then subtract 3, so that would equal 5. So we've got sec theta equals 5 over 3. Cos theta would equal 3/5. So if you are going to go down the polar route, you probably want to stop at this point. Like, if I was trying to figure out what the distance was between these 2 points, and you were going to try and find out what the coordinates were, I don't really want to take cos inverse at this point. If I do take cos inverse at this point, the answer is going to become like a messy decimal, which is making me think I probably would prefer to do the intersection in the Cartesian world. Like, we're thinking about when these 2 things intersect, which is probably going to end up being a nicer question, isn't it? But if we were going to persevere with this technique, once we know what cos theta is, we could think about the triangle. So theta, cos is adjacent over hypotenuse, so that means the opposite would be 4. Okay, and then what you've got there is, see this triangle here, like this theta that you're trying to find. That would be, it wouldn't be the same triangle, but that would be a similar triangle, and then you could figure out like what this distance was, and it would be a ratio, you know, that r value, compare it with the 5, and then that would tell you what that distance was, you know, when you compare it with the 4. But I think I'm gonna, after seeing how messy this is about to get, I'm gonna jump to the Cartesian world, because I think it'll be much nicer. Okay, so in the Cartesian world, if we think about when these 2 things intersect, We've got y squared equals 4 minus 4 times 3 over 4. Y squared would equal 1, so y would equal plus or minus 1. So much nicer straight away, isn't it? And if you think about your diagram now, the question's asking, find the length from P to Q. And we know that's got a coordinate of 3 over 4, 1. That's got a coordinate of 3 over 4, minus 1. We've got the y values. We already need the x values for 3/4. So we've got the y values of 1 and minus 1. So therefore, the distance from P to Q would just equal 2. So in this specific question, it's much easier to think about the Cartesian one. But I'm not going to say it's always going to work. Like, it depends on the question. You need to know both strategies. Like, should I do Cartesian? Should I do polar? And just how to convert between the two. Okay. For the next example, we've got r equals 6 plus 4 cos theta. The first part of the question asks you to find the area. I'm going to skip that out for this video because we've done that in the last video. But we're going to focus on the geometry aspect. Okay, so it says the point P is on the curve. So this is our curve. The point P is on the curve when theta equals 2 pi over 3. The point Q is on the curve when theta equals pi. So if you think about whereabouts these 2 points are, when theta equals pi, if that's our pole here, there's the origin. When we turn through pi, we go this way. So this point here would be the point Q. The point P would be 2 pi over 3, so if we turn through 2 pi over 3, we get the point P here. Okay, so for that angle, we'd get 2 pi over 3. And the question says, show PQ is parallel to theta equals pi over 2. So if I went from Q to P, this line here, let me just draw this out in a bit more detail without the curve. So if that's my pole there, that angle's 2 pi over 3. There's P, and there's Q. The line from P to Q, which would be like this line here, if it's parallel to theta equals pi over 2, like think about what does that look like? Like what does theta equals pi over 2 even look like? So it's parallel to this line. Theta equals pi over 2. There's like this half line here, isn't it? So it's basically saying, it's a fancy way of saying, look, it's a vertical line, isn't it? Like the line theta equals pi over 2 is any number along here. Sorry, any coordinate along here would have an angle of pi over 2. So we're thinking about, well, how can we show that P to Q is parallel to this? Alright. So the way I'm going to approach this is that let's just actually think about what these coordinates are, maybe in Cartesian form. So for P, when theta equals 2 pi over 3, if we sub it in, we can figure out the r value. So r would equal 6 plus 4 lots of cos of 2 pi over 3. Okay, because you'd be doing 6 plus 4 lots of minus a half. That gives us minus 2, so 6 minus 2 would give us 4. So we know this distance here is 4. Okay, if you think about Q, the coordinate for Q in polar form, well, when the angle's pi, if we sub pi into cos of pi is minus 1. So that would be 6 plus 4 times minus 1, which would be 2. So this distance here would be 2. We also know that angle there would be pi over 3. So we're aiming to show that this is like a vertical line. But to be honest, like I think maybe there's one way we can do it using the geometry of the situation, but I think we could probably do it using the Cartesian coordinates as well. Like If we know r and we know theta, then from this I would say, well, because x equals r cos theta and y equals r sin theta, that coordinate there in the x and y world that we're used to, if we do 4 times by cos of 2 pi over 3, and we already know what cos of 2 pi over 3 is because I've worked it out there, hadn't I? So if I do 4 times this, that coordinate is minus 2. So we can think about this as a minus 2 coordinate. The y coordinate is r sine theta. So if we do 4 sine of 2 pi over 3, that gives me 2 root 3. And if we think about what q is, I mean, I can see from my diagram, but we could sub it in. If we do 2 cos of pi, we'd get minus 2. And if we do 2 sine of pi, we get 0. So this coordinate here would be minus 2, 0. This coordinate here would be minus 2, 2 root 3. So like, we could explain it from a Cartesian perspective. We could say, well, clearly, because they've got the same x coordinates, both of these points would lie on the line x equals minus 2. So therefore parallel to theta equals pi over 2. Okay. It's your call. Like, you can do it from a Cartesian or from a polar perspective, but I mean, I think maybe in this one, if we think about that there, the other way of doing it from the polar perspective, if you just interpret what theta equals pi over 2 is, which is this vertical line. So how could we show that this was a vertical line? And we could maybe think about finding this distance, showing the Pythagoras works, because we've got this right angle triangle. Like, if that was not a vertical line, the angle wouldn't be a right angle, would it? So we could probably use some trig properties as well to justify it that way. But I think maybe the Cartesian one would be the easiest for this one. Okay. So the last part of the question says the line PQ intersects the curve again at R. Then the line R0, which means from R through the origin, intersects the curve again at S. Let's draw this out and see what this looks like before we try and answer the question. So we've got Q, which is here. We've got P, which was straight above. Yeah. The reason they were asking part B, by the way, was to help you with part C. Like, you need to realise that because this here is a vertical line, when we draw the line from P to Q, it'll intersect the curve again at R, which is straight underneath. Okay. Then we've got RO, which would be from R to the origin. And this intersects the curve again up here, which is the point that we're calling S. There's quite a lot going on with this one. Let's just pause for a second to think about what we know about the geometry of this situation. So now that I've drawn it on the curve, maybe if I draw it out again with just the key points without the curve in the way. Okay, look at this triangle that we've got here. So if we just focus on the symmetry over here on the left hand side for a second, we knew that total angle that way was 2 pi over 3. So I know that angle is pi over 3. I knew the distance was 4. But because of the symmetry, like as we go underneath here, that angle there is also pi over 3. Just by comparing those two. So if I know this angle here is pi over 3, then I also know this angle over here is pi over 3, don't I? So if we're thinking about the coordinates s, if I wanted to figure out what s was, I know that s is the point on the curve where theta is equal to pi over 3. And we actually get like a lot of symmetry here, like because that's 2 pi over 3, that's pi over 3, that's pi over 3, that's pi over 3, that's pi over 3. So we're working with loads of like 60-degree angles really. Okay. The question says find the length from P to S. Okay. So I've drawn another diagram to help us think about this. If we want the length from P to S, we need to look at this triangle here. Okay. Let's get this distance. So if we let theta equal pi over 3, r would equal 6 plus 4 cos of pi over 3. So r would equal 6 plus 4 times by half. So this distance r would equal 8 over here. So if we think about this triangle, and we want that distance, we can just use the cosine rule to figure out what this distance here is. Okay. So I think the video is long enough without me doing the cosine rule for you. So there we go, I've just done that quickly. So we do ps squared, this squared minus d times this. Subtract, I'm ended up with that distance there being 43. Okay. The last part of the question says show OPS is a right angle. Okay, so if we went from O to P to S, if I would have drawn this accurately, which I definitely haven't, we should be getting a right angle there. So all we've got to do is, if this is a right angle triangle, we know the sides. We just, to prove it's a right angle, we've just got to show Pythagoras works, because like Pythagoras would only work for right angle triangles, wouldn't it? So we can say 8 squared would equal 4 squared plus 43 squared. So therefore we know it's a right angle, Pythagoras works. Okay, thanks guys.